All right, in example 3, we want to determine the solution set for this system of inequalities. Okay, so now we have more than one inequality, and we want to find the set of all the points that satisfy both of these inequalities. All right, now we're just going to start by graphing the lines. So if I take a look at this first inequality, I just want to graph the line 4x plus 3y equals 12, because I know that that's going to divide the Cartesian coordinate plane into two parts. And on one side, I'll have points that make this true, and on the other side, I'll have points that make this false. But I just want to start by graphing the line. All right, so I'm just going to find a couple of points, because I know this is a linear inequality. All right, so probably the easiest thing to do would be to find the x and y intercepts. I'm just going to put in x equals 0 and see what happens. So this 4x becomes 0, so I end up with just 3y equals 12. So then y has to be equal to 4. Okay, so I know that that's 1 point. So 0, 4, assuming each one of these is 1 unit. So this is the point 0, 4. All right. And then another easy thing to do is just find the x-intercept. The x-intercept happens when y is equal to 0. So if y is 0, then this 3y term is just 0. So you just have 4x is equal to 12, and so x is equal to 3. So now I know the point 3, 0 is also on this line. Okay, so I can draw the line. Now I notice that this inequality includes the equals, right? Because this is greater than or equal to. So I'm going to make a solid line. All right, so let's see if I can draw a decently straight line through these 2 points. And okay, we'll say that's good enough. All right, so there's my line. All right, so let's take a look at the other line, this other inequality. All right, now I'm gonna graph the line first. So I'm just gonna find x and y values that satisfy this. If I put in x equals 0, that means y also has to equal 0. Okay, so there's 1 point on my line. It goes right through 0, 0. Right, so 0, 0 is on that line. Now I need to find another point. I can't just put 0 in again, because I just get the same point, right? So I'm just going to pick 2. If I put x equals 2 in, then y also has to equal 2. And so the point 2, 2 is on the line. All right. So I'm going to get a line that passes through these 2 points. So this is 2, 2. All right, so I'm going to try and draw a line. Well, okay, good enough. It's supposed to go through the points. Didn't quite go through the points, but you get the idea. All right, so that's the first thing to do, is just to graph the 2 lines. Now we just need to test some points and figure out which side of these lines contain the points that satisfy both of these equations. All right, so let's start with this red line, the 4x plus 3y equals 12. We want to find the points that make 4x plus 3y greater than 12. So I'm just going to test a point. Okay, so since I'm testing the red line, I'm going to write this in red, and so I need to pick. Whoops, I need to pick a test point. All right, now 0, 0. Now that's not going to be a candidate for the blue line, but it is a candidate for the red line because it's not on the line. So I could test 0, 0. That's always my favorite point to test, because it's really easy to evaluate the inequality for 0, 0. So if I put in the point 0, 0, right, putting in 0 for x and 0 for y, I'm just testing to see if this is true. Is this true? 4 times 0 plus 3 times 0 is greater than 12. Well, no, that's not true, because 0 is not greater than 12. So now I know that this point 0, 0 is not on the side of the line that I'm interested in. So that means the side of the red line that satisfies that particular inequality is this side. So I'm actually going to draw some little arrows. Those arrows just indicate, okay, I don't want, I could go ahead and shade it if I wanted to, but it just, I feel like it gets kind of messy if I try to shade that and then shade the other and then try to figure out which, you know, it's too much shading and it really makes it messy. So I'm just going to use little arrows to indicate, okay, that's the side of the line that contain the points that satisfy that inequality. All right, so now let's try the other line. I'm going to switch to blue because that line's blue. So let's pick a test point for that. Now I can't pick the same test point. I can't pick 0, 0 this time because 0, 0 is on the line. So when x and y are both 0, that's where they're equal. All right, I want to find, I'm testing for the inequality now, and so I want to find, I need to pick a different point. Okay, so let's just pick the point 1, 0. 1, 0 is right here. It's really easy to deal with ones and zeros. So let's test that point. We're testing it with x minus y. So x is 1 minus 0 is less than or equal to 0. I'm just put that x and y value into my inequality, and then I'm just asking myself, is that true? This is telling me that 1 is less than 0. That is not true. That is not true. Okay? So now I know that that point that I tested, 1, 0, is not on the side of the line that I'm interested in, right? Because I want x minus y to be less than 0. So I know it has to be the opposite side. So I'm going to draw some little arrows to indicate that it's the other side, right? It's not the side on, of the line where I picked up my test point. It's the opposite side. All right, now what we're looking for is the set of all points that satisfy both of these inequalities, okay? I want the points that satisfy both of these inequalities. Now, I know that it has to be on sort of the, I guess you could call it the upper above the red line and sort of, I guess, above the blue line. So if I pick the point out here, say I pick this point over here, it would satisfy the second inequality, but it would not satisfy the first inequality. If I pick a point down here, it's not going to satisfy either one of those inequalities. If I pick a point here, it satisfies the first inequality, 4x plus 3y is greater than 12, but it doesn't satisfy the other inequality. The only place that, the only portion of the plane that contains points that satisfy both are the ones where, you know, where all of the arrows are pointing, where all of their arrows are pointing. So the portion I want to shade here, maybe I'll shade it in green. The portion I want to shade is this region right here. Okay, it's all of that. It's that region right there. Those contain the points that satisfy both. Okay. All right. Well, hopefully that made sense. So I'll meet you in the next video for the next example.